All right, so let's see how we can use concentration units and use some dimensional analysis with concentration units to determine some useful information. So we're told a sample of air at atmospheric pressure and ambient temperature was found to contain 2.0 parts per million SO2. Under these conditions, the density of air is some gram per milliliter. What volume of this air in cubic meter will contain 1 gram of the pollutant? All right, so let's start with the concentration that we are given. We want to end up with what volume is going to give us 1 gram. And we have a density, so in other words, we want to get to a point where we will eventually divide a mass by the density. That will give us a volume, okay, in some kind of manner. And we can convert that milliliter to cubic meter. So 2.0 parts per million SO2 means that we have 2.0 milligram SO2 per kilogram of solution. And what is the solution in this case? It's air, because air contains the SO2 and the other stuff. So it's air. But what else do we know about the air? Well, we know there is the density of air is 0.0012 gram per milliliter, is the density of that air. So perhaps we can say 0.0012 gram air per milliliter. And then we just need to get that gram there to a point where we cancel it with kilograms. So 1 times 10 to the negative 3 kilogram air per 1 gram, of course, because I mean there's 1 gram, or there's 1 times 10 to the power minus 3 kilogram in a gram, or there's 1,000 gram in a kilogram. You can write it in either way, whatever works for your brain. And this gives us a unit of 2.4 times 10 to the power minus 9 gram per milliliter. Right, now this is important. It gives us gram SO2 per milliliter air. That's important to remember, because then we can determine the volume of air, because we technically now have a way to determine if because we have 1 gram of pollutant. So we just divide 1 gram of pollutant by the density of the pollutant, because we calculated the density of the pollutant, like I said at the beginning. So the volume of air is going to be equal to 1.0 gram of SO2 divided by the 2.4 times 10 to the negative 9. And let's write out the unit specifically. SO2 per milliliter air. Give you a value of 4.2, etc. times 10 to the power 8 milliliter air. But that's not the answer. We want it in cubic meter. So we again just do our dimensional analysis. There's 1 cubic meter in 1,000 liter. And that's not what we want. We want milliliter. Well, we need to cancel milliliter. And there's 1 liter in 1,000 milliliter. So you should get 420 cubic meter of air. And two significant figures all the way through. So yeah, 420. Okay. So that is that. The idea of this question is actually more dimensional analysis. You essentially want to get to a density of the pollutant, a mass per, yeah, so a density of it's a mass per volume. So mass of constituent per volume of solvent. So mass gram SO2 per volume air. And then we can use that to determine the volume of air that will contain 1 gram of that thing. And to do that, we use our conversion factors, or just basic, not conversion factors, but we can use some dimensional analysis to do that quite easily. Or, you can use some logic as well. But it's easy to see the units if you write them all out like that. All right. Thank you for watching, and I'll see you in the next video.